Once again, hearty welcome to the Math Revision Made Meticulous video series. Topic continuity and differentiability. Let us see about derivative of a function at this video. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per video from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answer. Let us see what do you mean by differentiability of a function at a point. Suppose f is a real valued function and a is a point in a domain. The derivative of f at a is defined by f dash of a is limit h goes to 0, f of a plus h minus f of a upon h. All of you know what do you mean by f of a plus h? It is simple, replace x by a plus h in the given function minus f of a, which is the value of the function at a upon h. Now all of you will be highly interested to know what is this h. H is a normal positive quantity. That's all, very simple. H goes to 0. Well, very close to 0. F dash of a exists only if the limit exists. What do you mean by limit exists? Left hand side limit is equal to right hand side limit. Limit h goes to 0 plus of this f a plus h minus f of a by h should be equal to limit h goes to 0 minus. Remember, h goes to 0 plus means h is greater than 0. H goes to 0 minus is h is less than 0. H goes to 0 plus is h is approaching 0 from the right hand side. That is the right hand side limit. H goes to 0 minus means it is approaching 0 from the left hand side. That is left hand side limit. H goes to 0 plus h is greater than 0. H goes to 0 minus means h is less than 0. You keep this in mind. Very easy for you to apply the limit idea. Well, at a domain means, as usual in continuity also we already defined, it is differentiable in its domain. If it is differentiable at all the points this limit should exist. Therefore the function is defined by f dash of x is equal to limit h goes to 0, f of x plus h minus f of f upon h. This limit already you have seen it in class 11. Whenever you want to evaluate the derivative of a function using first principle or using limits. Well, for y is equal to f of x, f dash of x is d by dx of f of x. It is denoted by dy by dx or y dash. We will be seeing it in the next chapters coming. Well, what are some results? If a function is differentiable, it is also continuous. But you should be a little bit careful. Every differentiable function is continuous, but every continuous function need not be differentiable. Differentiable function is continuous, but continuous function is not differentiable. Well, let us take one example. Modulus x is continuous. Already we know left limit is equal to right limit everywhere. But at x is equal to 0, f of x is mod x. What is 0 plus h? It is mod 0 plus h, it is mod h. F of 0 is 0. Let us try to get the limit of this derivatives. H goes to 0 plus of mod 0 plus h minus 0 upon h. H minus 0 by h. But remember, when h goes to 0 plus, h is greater than 0. Therefore, mod h is h. Therefore, the answer is 1. But in this other case, that is the left hand side limit, it will be minus h, because mod h is minus h if h is less than 0. That is the basic definition of modulus. Therefore, we are getting minus 1. Left limit is not equal to right limit. Therefore, mod x is not differentiable at x is equal to 1. It is continuous but not differentiable. That is why we made a statement. Every differentiable function is continuous, but there is no need that every continuous function is differentiable. And mod x is a better example. And you are seeing that mod x function, which is in the left hand side, it is totally a continuous function. But its derivative is mod x upon x is not continuous. Derivative of mod x is mod x upon x. It is not continuous. You are seeing that blue color curve. It is just having a break at 0. Good. Let us now try to prove some questions. Prove that the function is not differentiable at x is equal to 1. You have to prove that left limit is not equal to the right limit. We know that a function is differentiable when left limit is equal to right limit of h goes to 0 plus of f of a plus h minus f of a upon h. At x is equal to 1, let us find what is f of x. It is mod x minus 1. f of 1 plus h is mod of 1 plus h minus 1. I told you how to get that f of a plus h. replace x by a plus h. Here I am replacing x by 1 plus h. Therefore I am getting the final answer as mod h and f of 1 as 0. Fine. Let us take these values and let us continue with our left limit and right limit. Now here we are getting that mod h minus 0 upon h. Now here this is a right hand side limit. H is greater than 0. Therefore mod h is same as h. Therefore the answer is 1 by cancelling h and h. If you take the left hand side limit, here mod h is less than 0. Therefore its value will be minus h. If you cancel it, you are getting it as minus 1. Therefore left limit and right limit are not equal. Therefore this function is not differentiable at x is equal to 1. Very simple. But remember, this is because of the property of mod h. In right limit it is simply h. In the left limit it is minus h. Fine. Let us move on to the next question. Highly interesting. It is an integer function. It is not differentiable at integer values. Therefore, let us take a value x is equal to a, and this is the thing which should happen. Now I take one integer x is equal to a. I am going to show that it is not differentiable at integer values. Therefore, let me take what is f of a. It is greatest integer function a. F of a plus h is greatest integer function a plus h. F of a is a only. Therefore, I am ready with these values now. I am going for left limit and right limit. In the left limit and right limit, you have to be very careful with what is the value of a plus h. Well, at x is equal to a, let us find the right limit now. Limit x goes to 0 plus of greatest integer function a plus h minus a upon h. What is the nature of a plus h here? H goes to 0 plus. Therefore, it is a small positive quantity. For a plus h will be greater than a. Therefore, the answer is a. Therefore, a minus a. Therefore, the answer is 0. Let us go to the left limit now. In the left limit, we have to find what is a plus h value inside that greatest integer function. Here, a plus h is a minus 1 because h is less than 0. A plus h is a small negative quantity. It will be less than a. A plus h is less than a. Therefore, it is a minus 1. Therefore, when you put that a minus 1 over here, it will become minus infinity. It is non-zero. That is very tricky now. Therefore, left limit is coming as, right limit is coming as 0. Left limit is coming as non-zero. Therefore, greatest integer function x is not differentiable at all integer values. Please keep it in mind that already we have proved that greatest integer function is not continuous at all integer values. Kindly recollect. Fine. Let us go to the question number 3. Show that the function is not differentiable at x is equal to 2. Simple. We have to check this limit. At x is equal to 2, f of 2 plus h minus f of 2 upon h. Right limit we have to check. H is going to 0 plus. Therefore, 2 plus h is greater than 2. Which function to be taken? The opposite to greater than 2 to be taken. Therefore, I am taking 2 times 2 plus h minus 5 minus of minus 1. Because f of 2 is minus 1 by upon h. Therefore, I am getting 4 plus 2h minus 5 plus h, and when I do the simplification, I am getting the final answer as 2. Check out f of 2 is in this problem, it is minus 1. Good. Let us now go to the left limit now. The left limit is simple. Here h goes to 0 minus mean 2 plus h is less than 2. Which to be taken? That x minus 3 to be taken. F of x is equal to x minus 3 in this case. Therefore, 2 plus h minus 3 minus of minus 1 because f of 2 is minus 1. Simplify. You will get the answer as 1. For left limit not equal to the right limit. Therefore, the function is not differentiable at x is equal to 2. And check out this function is continuous at x is equal to 2 but not differentiable at x is equal to 2. Well, once again I am taking a problem where continuity and differentiability can be clubbed in the exam. That is, show that the function is continuous but not differentiable. Fine. Let us first check continuity. At x is equal to 2, f of 2 is 6. As x is equal to 2, we have to check RHL and LHL. Therefore, 2 plus is greater than 2. Therefore, 5x minus 4 to be taken. Therefore, the answer is 6. X goes to 2 minus, therefore, less than 2 to be taken. Therefore, 2x square minus x taken. It is also coming as 6, where limit x goes to 2, f of x is 6. It is same as f of 2. therefore it is continuous at x is equal to 2. Fantastic. Therefore it is very simple. We have just to prove that continuity already we have seen in the previous chapter, previous topic, and we have proved that it is continuous at x is equal to 2. Let us now go for checking the differentiability. Therefore we have to check x goes to 0 plus. Here 0 plus means 2 plus h is greater than 2. Which function to be taken? 5x minus 4 to be taken. I am taking it. F of 2 is 6. I am directly substituting now. 5h upon h and h getting cancelled. Therefore the answer is 5. Let us go to the left limit now. Right limit value is 5 in differentiation. Here once again, h goes to 0 minus means 2 plus h is less than 2. Which function to be taken? Opposite, it is 2x square minus x. There were 2 into 2 plus x the whole square minus of 2 plus h minus 6, because f of 2 is 6. Simplify and you will get the answer as 7. Therefore limit is not equal, therefore not differentiable at x is equal to 2. We have proved that the function is continuous at x is equal to 2, not differentiable at x is equal to 2. Let us go to the next question where we have to check the function is differentiable but find the values of a and b. If they are checking that it is differentiable, the meaning is differentiable at every point. I am just taking here the function is defined at 1, therefore I am assuming that it is differentiable at x is equal to 1. Therefore as f of x is differentiable at x is equal to 1, it is also continuous. First let me use both the ideas, continuity and differentiability. Therefore what is the meaning of continuity? Left limit is equal to right limit of the function is equal to f of 1. I am equating. For 1 plus I have to take bx plus 3. For 1 minus I have to take x square plus 3x plus a. Check out. And f of 1 is I have to use that x square plus 3x plus a. Therefore I am getting one equation that is b plus 3 is equal to 4 plus a, or otherwise a minus b is equal to minus 1. I am keeping it ready. Using continuity I got a equation involving a and b. Now let me use the condition differentiability. Let me get the second equation using a and b. Is it differentiable? Therefore left limit is equal to right limit. Left limit is 1 plus h, therefore it is greater than 1. Therefore I have to take the greater than 1 function opposite to that. And h goes to 0 minus means it is less than 1. I have to take the function opposite to less than or equal to 1. Well, f of 1 is 4 plus a, already we have got it. Now let us put it now. Limit h goes to 0 of f of 1 plus h is we have to take bx plus 3. Therefore b into 1 plus x plus 3 minus 4 minus a upon h. For this h goes to 0 minus I have to take x square plus 3x plus a. Therefore 1 plus h the whole square plus 3 into 1 plus h plus a minus 4 plus a by h. Normal simplification in the left hand side and right hand side. Already I know that a minus b is equal to minus 1, therefore b minus a is equal to 1. I am substituting that and I am getting continuing now. In the left hand side I am getting bh by h is equal to limit h goes to 0 5h plus h square by h. I am cancelling h in both the left hand side and right hand side. I am getting limit h goes to 0 of b is same as limit h goes to 0 of 5 plus h. Therefore b is equal to 5. You are getting the value of b directly and already have a equation b minus a is equal to 1. Therefore I am getting a is equal to 4 and b is equal to 5. Very interesting problem, because this problem you have been asked to get the value of a and b, telling that it is continuous at x is equal to 1 and differentiable at x is equal to 1. But in the question it is simply given that it is differentiable, but I have used the condition that continuity I got one equation a and b. I used differentiability, I got another equation in a and b. Little bit tricky question, highly interesting. Every differential function is continuous. Well, thank you. Success is dependent on efforts. All the best. Thank you once again.